I hope so. Like, I got. All right, here we go. Coterminal angles. Coterminal angles are angles whose terminal sides are in the same position. Angles whose terminal sides are in the same position. Some of you guys had a worksheet, all of you guys had a worksheet last Friday. And as you work through it, you noticed, hopefully, after a while, that some of those angles end up being in the same spot. For example, towards the end of your work, you came up with an angle of 11 pi over 6, which you guys all know is how many degrees? 330, very good. And shortly after that, you had negative pi over 6. And when you figured out the terminal point for negative pi over 6, you saw it was in the same location. You're like, hey, they're the same. That's because negative pi over 6 and 11 pi over 6 are coterminal angles. They're in the same position. So let's look at any given angle. We'll say 110 degrees. If you have a 110-degree angle, we sketch it in the second quadrant and show the appropriate rotation. I would like to figure out another angle that's positive, whose position is in the same place. In order to do that, so I draw an angle, same position, 110 degrees. But instead of going to 110, I'm going to go around once more. And so I determine that angle by taking 110 and adding 360 degrees to it. And I get 470 degrees. That means that 110 degrees and 470 degrees are coterminal. They are in the same position. They have the same terminal point. Everybody good? So you can always take an angle and add 360 to it and come up with another angle. You can also subtract 360. So we want to come up with a negative angle, just go in the opposite direction. That will be 110 minus 360. And that would produce for you negative 250 degrees. Negative 250 is coterminal with 470 and 110. The truth is this, is that there's an infinite number of coterminal angles for every angle. Because we could go around more than once, couldn't we? You could. And so, yeah, we'll get to that later. Everybody good? All right, let's do a couple together. And you're going to have some time to work on your assignment. We have two small assignments today. This is one. We're going to give you some time in class to work. We got negative 140 degrees. Draw an angle here, angle here, angle here. I'm going to start by drawing negative 140 degrees. Does anybody know what quadrant negative 140 will place me in? The third, very good. Anybody got an issue with that? We all okay? All right, I'm going to do another negative angle. It's going to be in that same position. And I'm going to come up with another negative one by going to negative 140 and then doing another negative 360. So it's negative 140 and then a negative 360. That makes negative 500 degrees. So negative 140 and negative 500 are coterminal. Are we all okay with that? If I want to find a positive one, well, no big deal. Instead of going in the clockwise direction, I go counterclockwise, kind of like we're used to. So I want to determine that angle. And that would be negative 140 plus 360. And I get 220 degrees. All of those are coterminal. On today's assignment, you'll sketch the first angle, and then you'll determine one that's positive and one that's negative. So this is reinforcing the idea of sketching the angle appropriately, and then it's just trying to understand conceptually that you can either travel in the reverse direction or positive direction, come up with it. Now, what if we have an angle like number 8? How is number 8 different? It's a radian, and we can sketch angles that are in radian measurement. And if they are in radian, you leave your final answer in radian form as well. Now, some of you know where 5 pi over 4 is located. Is 5 pi over 4 more than 1 pi or less than 1 pi? It's more than 1 pi. In fact, some of you remember 5 pi over 4 is 225 degrees. And so we are going to go more than 1 pi. We're actually going to go right there. So you have 5 pi over 4. Would you like to do a positive one or a negative one? Which one do you want to do? Positive? Okay. So I'm going to go that same location, but I have to go around more than once. So I'm going to take 5 pi over 4, and instead of adding 360 to it, anybody know what I'm going to add to it? 2 pi. Thank you, Logan. I'm going to add 2 pi. Well, if I add 2 pi, it's got to have common denominators. How do you make 2 pi with a denominator of 4? 8 pi over 4. Isn't Logan smart? We could do the same thing, except we would go in the opposite direction. And you would take 5 pi over 4 and you would subtract 8 pi over 4 and you get negative 3 pi over 4. What do you think about that? Not too bad? And I want to be clear in the end, folks, that I know that you can all add 360 and subtract 360. If that's what this assignment becomes to you, simply adding 360 and subtracting 360, or adding 2 pi and subtracting 2 pi, then we really haven't accomplished what we want to. What you want to be able to understand is the rotation. And hopefully it should click in your brain that positive 3 pi over 4 looks like that. So negative 3 pi over 4 looks like that. And that these angles, 5 pi over 4, 13 pi over 4, negative 3 pi over 4, they end up arriving at the same region. So you want to try to think and invest your time into it. You're going to have about 10 minutes to work on this right now in class. Go get them! All right, here we go. All right, so we're going to wrap up our introduction in trigonometry by talking about the applications of this whole radians piece. And you guys are going to jump to this spot in your notes where it talks about applications. Tomorrow we have a very invigorating lesson, and the lesson is going to be on the trigonometric functions such as sine, cosine, tangent, cotangent, cosecant, so on and so forth. And in case anybody here is interested, just want to throw this out, I wrote a 10-page paper on the sine function in grad school, and you would be welcome to read that if you would like to. Yeah, you can. You don't want to? No takers? No extra credit? You want to read it? All right, Logan, I will bring the 10-page paper on the sine function to you tomorrow. Thank you for taking me up on that. On my book. I do have a book. I do have a book. We'll look at that later. Okay. So, let's talk about applications. You guys all know about arc length. And I don't know. What did you just say? Okay. Yeah, you are like, you just make fun of me each day I stand up here. Whole bunch of anti-authority. All right. So if we have kind of this region of a circle and we want to find the arc length, we call the arc length S. And you learn this in geometry. That doesn't mean that I expect that you remember exactly what it is. When I put the formula up there, I hope that you guys are able to say, oh yeah, I kind of remember seeing something like that. So some of you guys are suppressing geometry as though it was like a harmful part of your youth. All right? It's like you witnessed a murder or something. I'm trying to put it behind me. Geometry shouldn't be that way. So arc length, S is equal to, arc length is just a a section of the circumference. Agreed? What's the formula for circumference? 2 pi r. And what we do is, in order to come up with a section of the circumference and not the whole thing, is we multiply it by theta divided by 360. And that gives us that section of the circumference that we actually want. That formula looks somewhat familiar? Okay. And if you're looking at area is that kind of that pie shaped thing in the middle, that pizza slice or whatever it would be. And area, instead of doing circumference, we do area. So what's the formula for area of a circle? Pi r squared. And we take that and we multiply that by, let's see, theta over 360. Yep, that sounds really good. Okay, so what I'm going to do here is that's if you're working in degrees. And the fact is that a lot of people don't like those formulas because they seem rather large. So let's make them simple. You want to make it simple? Let's make it simple. And so I got S is equal to, watch me go here. I'm gonna do R times theta times pi over 180. Yep, so let's convince ourselves that those are the same. Do I still have the R? Do I still have pi? Do I still have theta? Do I have the 2 over the 360? It's all still there. Does that look familiar? Theta times pi over 180? Remember when we convert from degrees to radians, we simply take theta and we multiply by pi over 180. And we end up with a new angle that's in radian form. So S equals R times just theta is a formula if you are working in radians. So the first one's if you're working in degrees. This is if you're working in radians. Is that cool? Yeah, that's a lot simpler than the first one, isn't it? Yeah. Yeah, put a circle and then put a line through, and that'll, yeah, an egg with a crack down the middle. Yeah, this is actually how you spell the letter theta in Greek. That's how you spell theta. Yeah. Yeah. Ooh, I will share that with you in a moment here. Okay, so this one, we're going to take this. I'm going to go k is equal to 1 over 2 pi r squared. No. That was a bad job, Mr. Gens. K is equal to 1/2 r squared with theta pi over 180. Is everybody okay and convince themselves that those two are the same? I've just rewritten them. Because the 360 is the 2 times 180, right? I still got the r squared, I got theta, I got pi. Well, theta times pi over 180, that's just your conversion of degrees to radians, right? So this becomes area of a sector is 1/2 r squared theta, where theta is in radians. So those are two formulas that are nice for us to use. I don't expect you to remember those for the test. I give them to you on the test. But if you would like a challenge, walk up to every trig test with no notes and see if you can just remember how they came and where they came from. It's up to you. All right. So it says, find the angle in radians that satisfies the conditions. We have a radius of 7 in a circle. We have an arc length of 3. So we would like to find theta. Well, we can use our formula for arc length. And the formula for arc length is very simple. S, or arc length, is equal to r times theta. What is S? 3. What is r? So therefore, 3 over 7 is equal to theta. So theta is 3/7 of a radian. Maybe like, say, 25 degrees or something like that. But it produces a measurement in radians. You try next one on your own. you can have theta is 13 over 4 or 3.25. I just want you to understand this problem, the nature of the way I've expressed it. Notice how I drew the arc to be more than 180 degrees. Does anybody know how I knew to draw it more than 180 degrees? 180 degrees is how many radians? 180 is the same as pi, 3.14. Well, we came up with more than 3.14, didn't we? So it's slightly more than half a circle. Okay? Let's look at the type of problem you're going to receive on the test. Find the length of an arc on a circle of a radius 24 that subtends a central angle of 60 degrees. I have a circle. What's the radius? 24. What's the central angle? 60 degrees. And what I would like to find is the length of the arc. Do I have a formula for arc length? What is the formula? Great. So S is equal to, what is R? 24. What is theta? And that's where you get the problem wrong on the test. See, this is a really nice formula to use, right? But it has a condition. Theta must be expressed in radians. So it's pi over 3. 60 degrees is the same as pi over 3. So as long as you do that, you can use this formula. If you wanted to use 60, then you would have to go back and use this formula instead. 2 pi r times theta over 360. That's what you'd have to do instead. But that formula was bulky and long. It was no big deal to convert 60 to pi over 3, was it? Super easy. Multiply it. 24 times pi over 3 is going to be 8 pi. That's the length of your arc. Suppose there is a second component to the question, and it said find the area of a sector with the same conditions. Then you would use your sector formula. K is equal to 1/2 r squared times theta. So K is equal to 1/2 times 24 squared, and theta is pi over 3. Again, you use pi over 3. You don't use 60. If you're going to use that type of formula, you must use radians. I turn on my calculator, and I do 0.5 times 24 squared. I get 288 divided by 3, and I get 96 pi. If the problem says express your answer in terms of pi, there's your answer. Suppose the problem says express your answer to the nearest tenth. Well, just take 96 and multiply it by pi. And when you do that, you get 301.6. So whichever one you want to use depends on what the problem is asking for. On the test, I would accept either answer. We good? So figure out how to use arc length and sector area. You were ready. Good job.